All right, guys, welcome to the notes on solving quadratic equations by graphing, which is 9-2. Um, we are also going to take a brief look at 9-3, where we do some transformations of these graphs, which just means a fancy math way of saying we're going to move them around. So let's take a look here. Solve by graphing. We've been talking about this all year. Um, the solution is where it crosses the x-axis. Pretty simple. If it crosses the x-axis twice, it's going to have two solutions, and real solutions. In Algebra 2, you'll learn about um, imaginary solutions. But two real solutions here, one real solution here, none. No problem. Um, I would like for you guys to graph these in your graphing calculator or by hand, whichever you prefer. I don't mind the graphing calculator if you know how to use it. And then obviously we can check these a variety of ways. So we graph this, we see that it intersects it at 2 and at 4, and so the answers are, or sorry, at -2 and 4. And so the answers are -2 and 4. It's simple as that, guys. So in your graphing calculator, preferably, or by hand if you must. If you could please graph these 1A, 1B, and tell me what you get. Go ahead and do that now. All right, you're back from graphing. Again, hopefully in your calculator, guys, if you're really struggling with your calculator, let me know, and then I can show you how to do these pretty quickly. But G-Solver or in a Casio or Second Calc, Second Trace, which will give you the calc options in a TI. We looked at these last time a little bit. So hopefully for 1A, you got 3 and -6, and for 1B, you got 1 and 3. And again, like always, if you didn't, make sure you make a note of it, and we'll go over those in class. We have something called a double root. So the solutions in example 1 were two distinct numbers. Sometimes that's not the case. So for example, on this one, this graph touches right here just at one point, and that's called a double root. This happens when we have a perfect square trinomial like this. And so when that happens, it's okay if you solve these and you get 1. Big key to solving, always make sure we want to, and we've talked about this, we always want to get everything equal to 0. So get everything on one side. It doesn't matter which side, but you get one side equal to 0. So go ahead and pause this, and pause the video right here, and get answers for A and B. All right, you're back. Hopefully for A, you got x equals 5, and for B, you got x equals negative, x equals -4. And as always, you can just plug these numbers in, see if they work, and make the equation come out true. Sometimes when we graph, they don't intersect the x-axis at all. When that happens, when there's no x-intercept, there is no solution. If there's no solution, we're gonna put a circle with a line through it. It means the solution set is null. There's nothing there. So take a second, graph 3A and 3B, and make sure that you get no solution for both of those. Go ahead and do that now. You're back. Hopefully, like I said, I gave you the answer before you left, but you want to make sure that your graph matches up with that. Hopefully when you graph those, you get no solution for each. Estimating solutions. So we can make a table either by hand or in our calculator. I'll show you how your calculator does it in class. You guys can figure it out, and we talked a little bit about it last time, but we can estimate solutions pretty simply. So we graph this, and we see the x-intercepts are in between -5 and -4, in between -2 and -1. So we can make a table in our calculator, and we can ballpark some answers. So take a second, and using your calculator, the table function, or the graph function if you know how, get me some estimate answers rounded to the nearest tenth for number 4. All right, your answers here should have been 0.4 and -3.4. And again, if you're struggling with your calculator, you're going to continue to struggle. You got to make sure we ask a lot of questions in class when we get those, when we meet tomorrow. So this one, a goalie kicking, so we're using this equation in our calculator to model this. We talked about this last time also. We need to find the roots to find out how long the ball is in the air. So from here to here, and it ends up being about 4. Okay, so it's about 4 seconds. Go ahead and try number 5. What if the velocity was 55 miles per hour instead of, or 55 feet per second miles per hour? That'd be an amazing thing if you kick a ball 55 miles an hour. I dare say you'd probably be a professional something. 55 feet per second, 2 feet off the ground. So change this equation so it models that, and then find out how long the ball is in the air. All right, you're back, and the answer here was 3.5 seconds. Okay, that is it for that section. What I'd like for you to do is try to answer 1 through 9 here. You can do that now, or you can wait till after we talk about 3. So if you're doing it now, pause the video. If you're not doing it now, don't pause the video. And then we'll check out chapter 9, section 3, and you can go back and do them at the end. So here is chapter 9, section 3, where we're going to talk about transformations. One transformation that we're going to talk about here is called a translation. A translation is simply by taking a graph and moving it. We can move graphs up and down. We also have the ability to move them left and right, but we're only really going to look at up and down as far as our translations. And it really simply is this: if we take y equals, or f of x equals x squared, and we add a constant to it, it moves it up. If we subtract a constant, it moves it down. It's really that simple. So if we look at this graph, if we look at this graph right here and just describe it, this graph has moved up 3, shifted up 3. This graph has been shifted down 4. Right? Take a second. You can say shift, by the way, or translate. It's fine either way, shift or translate. Take a second, pause the video, and tell me how 1A, B, C, and D have been translated. Go ahead and pause the video now. All right, you're back. This one is down 7. This one is up 5. This one is down 5. And this one is up 1. Probably pretty simple or self-explanatory. Two other kinds of transformations. One is a dilation, and another is reflection. A dilation is a stretch or a compression. So if there's a number out in front of the x squared, and that number is more than 1, okay? If it's more than 1, then we are stretching the graph. If that number's between 0 and 1, then we are squishing or compressing the graph, okay? So let's look at these. Here, in between 0 and 1, that's a compression by 1/2. This, greater than 1 and a shift of 2, so that one has been stretched by 3 and shifted up 2. Go ahead and take a second. We're not graphing these, we're just describing. 2A, B, and C, what is happening? Go ahead and pause the video here and tell me. All right, you're back. This one is a stretch by 2. This one is stretched 5 and translated down 2. This one is a compression by 1/3, and it's been translated up 2. All right. We also have the ability to reflect our graphs. Whoa, too far. We also have the ability to reflect our graphs, and we can reflect them 2 ways. We can reflect them across either axis. So a negative sign right here out in front would reflect the graph across the x-axis. A negative sign on the inside would reflect it across the y-axis. Okay? Let's take a look what that looks like in an example. So here we have negative 2x squared minus 3. This has been reflected across the x-axis, stretched by 2, and shifted down 3. So it's got 3 transformations. Go ahead and take a second, see if you can do 3a and 3b. Tell me, describe those functions as best as you can as it relates to the original function. All right, you're back. 3a has been reflected across the y. It has been stretched by 2. And it has been translated down 9. This one has been reflected across the x. It has been compressed by 1/5, and it is translated up 3. Okay? Here's a test type kind of question. So which is an equation for the function? So we have this function. It's upside down. So because it's upside down, I can eliminate that one and that one. So far, so good. Then it's been, I don't know what to do with this 2 and 1/2, but this -5 and +5, I can see that it's been shifted up 5. So I know it's not B, so this one has to be C. The easiest way to do these kind of problems is to eliminate the ones that you know it isn't. So which of these is a graph of that? Go ahead and pause the video right here. See which one you think that is. Go ahead and do that now. All right, you're back. Hopefully you said H. Okay? Some practice problems on this one for you to try. Here's 1 through 7. Give those a try. Remember to try the other ones also. And when you get back next class, we'll make sure that everybody is able to use their calculators as best they can. All right, see you next time. Bye.